storage, engine storage and things, engine cradles and things of that nature. So that's the space we are working in. So over the last few years, we have started looking at TCF in a number of ways. For our industry, basically compression molding is of high interest to the automotive industry. Of course, vacuum infusion for the wind industry. So that's the two processes we have looked at using NCFs of TCF, that is non-crimped fiber produced from textile grade carbon fiber. Material forms in these, we have also looked at things such as chopped strand mats, wet laid mats, compounded pellets, and SMCs. So we have continuous on the left and discontinuous on the right. A range of resins, thermoset and thermoplastic including, that is epoxies, vinyl ester, urethanes, as well as thermoplastic resins such as helium, which has been an emerging resin for recyclability. And then other reinforcement for comparison have been Zoltec, as well as some of the recycled mats from ELG, CCS, Vertega, etc. So the goal of this few years effort has been to start looking at creating a database that comprehensively captures the processes, material forms, reinforcement, and resins. And we've been, I would say we are making good progress. We're not there, obviously, it's a very large undertaking. In terms of NCF itself, Shomrat is the partner where they convert textile grade fiber, which is not the most easiest fiber in the world to handle. It is like a snaking, a horsetail kind of fiber. So in terms of keeping the tension control and being able to produce NCFs, Shomrat has done an excellent job. So typically 220, 240 GSM C-ply is their trade name in this, which has been adopted in creating some of the databases in the scheme of things. So just I'm giving you tons of data, but I'm just giving you one or two snapshots here. So if you look at the modulus, every single material produced, composites produced by vacuum infusion and by compression molding were tested independently at two labs at UT and Oak Ridge. And they, without communication between the labs, so that to get to fully non-biased data. I'll just point you to this one histogram here. The orange is the UT data, the Oak Ridge data is in blue. You can see the modulus of this exceeds about between 70 to 75 GPa, which is actually very comparable to that of Zoltec and other non-aerospace grade materials. The Z is the Zoltec fiber here in this case, which was also used as comparison. And we did this for different orientations, different cross plies as well as angle plies. And this has been systematically done for tension, compression, interlaminar shear, flexure, and impact testing. So that forms a good collection of properties with TCF in two different processes, being vacuum infusion and compression molding. And this is just a table for more completeness for your review at some point. One of the challenges with TCF, as some of you know from before, has been that it was packed in a brown paper packing to separate each layer from the next. And obviously this was not only expensive, but actually resulted in a lot of complications during processing at rapid speed. So what had to be come up with a spooling strategy where you would not require that brown paper wrap. So one of the IACME projects looked at McCoy was a partner to look at a spooling strategy for this. We also looked at other things which I'll go slide by slide, but this kind of forms the continuous fiber portfolio within TCF, that is spooled fiber, pultruded, hot melt impregnated, and vacuum infused, for example. So the McCoy project, just to get into it a little bit more, this is the standard format of the LCF fiber or TCF fiber as it was spooling and initially, but now with this new development and the creel sets that have been designed, we can basically get a paperless packaging for downstream processing. So this was a DOE milestone to produce, I think, hundreds of meters of this without any crimping or a defect in the spooling. And this now has become an adoption for the downstream processes. For example, wind blade spar caps are continuously using carbon fiber now or looking at it actively. So textile grade fiber is a strong candidate in this industry. This was a 9-meter wind blade made out of thermoplastic helium in the program. And the goal on this, although the TCF spar is not installed on this one, the work done, developmental work is leading to additional blades to be produced using the TCF spar cap on these applications. Initially, the trials were held at Martin Pultrusion with the challenges of dealing with the spooling and brown paper wrapping. And despite that, just showing you some comparison of Panex pultruded versus TCF epoxy pultruded. And you can see that the modulus is actually very comparable between the two. Obviously, there's a knockdown in strength, more on the tension strength than the compression strength. But this kind of studies have to be expanded quite a bit to compare the two together. Pultrusion, CFTF now has a IACME enabled Strongwell was the partner Pultrusion line, which now provides the ability to test out the fibers produced right there next door. In fact, right next to this adjacent space, and looking at dyes, etc. for thermoset and thermoplastic pultrusion with the textile grade fiber. The other format that is used in this is the so-called lace stitch process, which is becoming popular in aerospace and high load bearing parts, etc., where you take the fiber and locally reinforce it with the anything from carbon nanotube threads to very fine threads, high tensile strength threads, to be able to create preforms, which then have very high G1C values and fracture toughness. So this was in collaboration with Michigan State, at, where the textile grade fiber has been converted to this lace stitch preforms. And then if you consider the, like here's an example of a automotive control arm, but by doing controlled stitching, you can almost see that your, if this was this tensile strength of a coupon without a hole, with the proper stitching and even with the hole, you can almost get back your original properties. As another way that TCF has been used is in thermoplastic forms, where the TCF has been used to produce laminates of helium thermoplastic. And then these can be just heated and stamped to shape. So we demonstrated this in a die-a-day theme in the IMTS show in Chicago, where these are additively printed, metal additive printed tools, where the TCF helium systems were taken and stamped to shape in a matter of like 30-second cycle times. And this was all done on the show floor. So this is a very viable process, even for large scale parts of this nature. Coming to some of the discontinuous forms here. Now, one of the things, of course, TCF has been extensively looked at in pellet form with a range of resins, including polypropylene, PA6, PA66, etc. Going through the pelletization step. And then in the IACME SURF facility in Michigan, that is scale-up research facility, using the large-scale injection molding, like 3,500-ton injection molding with actual automotive tools. This is a quarter fender here, produced with this textile fiber polypropylene, as well as other representative components. So completing this cycle has been effectively demonstrated. This is just an example that the study went further into looking at the thermal DIC to look at uniformity of the fiber spread in these parts, as well as dimensional stability. All that has been evaluated and produced in publications now. Along the way, we also developed multiprocess tooling. So this particular tool is interesting in that it can be used in compression molding as well as injection molding, just by a few swaps of some hardware in the tool. This particular tool has extensive designed ribs of different natures. So one can get a range of coupons to evaluate fiber flow, fiber orientation, fiber distribution in the processes. So in a single tool, it can be used to evaluate multiple processes. And this was an IACME project with the Valley Enterprises in Michigan, a Gemini group. These are an example of that, injection molded parts. Again, the cycle times here are like 30 seconds. This is TCF in urethane size TCF in TPU resins, thermoplastic polyurethane. Again, compounded pellets. And here the comparison is with LFT or long fiber thermoplastic. Another development of interest to you is that the MDF now, IACME has installed a SMC line. The SMC here is very tailored in that it can be used for chopping everything from standard glass to basalt fiber to 24K, 50K, and 300, 450K TCF. So the cutting modules are interchangeable to accommodate the different formats. But SMC here then could be used to innovate a lot in the space of recycling as well as in the space of the innovative thermoset resins. And this line is at the new MDF facility now. Here are some examples. Excuse my crude passing of the stove, but this was some initial trials to evaluate the cutting of the TCF. And we have demonstrated uniform cut quality with the modules that have been designed. And some custom TCF SMC has been designed and tested. Some of that has been overmolded with structural SMC. To see now overmolding is becoming a big interest in automotive parts. So here the substrate is the conventional SMC, and then the is backed by a TCF C-ply. And you can see the improvement of both strength and modulus quite dramatically with the addition of a very thin layer of continuous TCF with conventional SMC. Another development has been the hot melt impregnated tapes. We have designed and developed a line to take the textile grade fiber and now essentially impregnate it to produce white tow. So you're all familiar with Solvay, Tenkate, and Torre tapes, which are typically 24K tapes. This tape is more like a 330K tow. So getting the challenges of impregnating, getting the tension control, so many small details in the process optimization. But a DOE milestone has been met by producing 100 pounds of this very acceptable quality. And now we are using that material in automated tape placement trials, as well as tapes around peripheries to produce overmolded like parts with SMC and long fiber, discontinuous fiber with this tape as continuous fiber. I will skip this slide, but it just demonstrates the cost of or cost savings achieved by inline impregnating a tow with a carbon fiber line. And some IPs have been filed on this, and now it's in the process of licensing. Sorry, I'm going fast. So another one is the Endeavor Composites, is a company by our own graduate through the Innovation Crossroads program. And that company now is looking at wet laid processes using TCF as well as recycled fiber to produce a range of these discontinuous mats, which can be used as substrates or as primary structures based on the nature of application in mass transit, as well as secondary, tertiary, aerospace, things of that nature. So this is again another process that has evolved over the period of time. A lot of techno-economic analysis has been conducted with TCF for different types of sectors. This is an application for a wind energy spar cap, where we looked at the standard glass Vartem blades, standard carbon fiber Vartem, textile grade or low-cost fiber Vartem, and low-cost fiber pultruded spar caps, and showed the significant savings of both weight savings and energy savings using the approaches of textile grade with properly pultruded spar caps would be a very viable economic option, almost rivaling or could replace glass in some applications. So I'll just, in the few minutes remaining, switch to my recycling portion of the talk. So IACME has had a robust recycling set of projects. So since its formation, 55 or so projects have been formed, of which I would say 10 or so projects were focused around recycling. And this is not only carbon, but glass and other fibers as well. A roadmap strategy was developed, which is available for your review if you have interest in looking at it. It's about a 5-6 page comprehensive document that lays out by year. Now this is gone in time, but what would be the priority activities in wind, vehicles, compressed gas, and cross-cutting. Obviously, we are now going through this systematically to see which boxes were checked and where there are still gaps. And the industry voice was strongly heard, and it fell in the category of benchmarking needs, LCA modeling needs, looking at reclamation separation technologies, intermediates that become very much robust for the end user, and then what are the industry needs and opportunities. So we have systematically broken down that themes, and obviously I can't go into all of that, just giving you a flavor of what was done. So like I said, a number of IACME projects focused on recycling. These are all the companies specific to the recycling partnerships, and some you recognize as big brand names, some are startups like Carbon Reverse is one, Endeavor was the other one that I mentioned. Of course, I think the next speaker is Carbon Conversion. So I had a lot of colleagues in basically Jim Steik and Mark Janney, who really, Mark Moher, who really supported IACME in the formation years. And Vertiga was a company that actually built over the period of IACME with Andrew Maxey in Colorado. So a lot of success stories here on the recycling front. In parallel, last year, I know many of you probably know the MDF has significantly expanded its reach in the high bay, about 60,000 square of high bay, in which the fourth bay is all about circular economy, advanced composites and biocomposites. So this has been a very significant co-investment between IACME, Oak Ridge, and UT to produce a one-of-a-kind set of assets that are in combo with machine tools, BAM, and metrology. So this is a list of the equipment. If you're interested, and I'm happy to go into anything there. As all of you know, recycling strategies fall under shredding, solvolysis, pyrolysis, and cement kiln. Of course, companies look at different strategies, like the Vertiga process is based on solvolysis. I believe the CCS process is based on pyrolysis. Shredding compounding is extensively used across the industry, and compounding cement kiln, this was more for glass fiber recycling, but this is a comprehensive set of evolving strategies for recycling. And in IACME, this is a slide from Soidan Ozgan, the colleague who leads recycling for IACME, looking at composite manufacturing / scrap, end of life recycling, and product development from reclaimed carbon fiber. So these were the three areas under which the projects were defined. And there's a lot more granularity on each of these projects. If you're interested in anything specific, I'm happy to try to get that to you or answer that. This was a project with ACMA and the American Composites Manufacturers Association, a very signature company for our industry, organization. And they have the voice of the industry. They led this project from the industry side. This was primarily on glass fiber recycling with boats and wind blades and large infrastructure panels, etc., using the thermolysis process. And this was also the genesis for formation of Carbon Reverse, which is now based in Knoxville as a very promising startup company. The recycling project with BASF was specifically focused on using reclaimed carbon fiber for Class A parts for automotive, which has really never been done before. So here the technology was looking at rock tool, induction heated tooling, where you basically bring in the BASF polymer with the recycled fiber to produce Class A finished panels. So this project is still ongoing. Even after the IACME years, it has gone into more of an industry-led and sponsored project, a very high interest project for BASF. Other areas are scrap from manufacturing, from the aerospace scrap. This is again carbon conversion solutions. Mark Janney at the time, they looked at recycled fiber going from aerospace into a part that goes into a corvette, like a cradle. Carbon PPS reject seeds that have gone back into blended thermoplastic discontinuous fibers, processed with extrusion compression molding to produce doors for mass transit applications. So a number of these innovations have stemmed from such availability now of recycled carbon fiber. One of the things IACME is looking at developing some automated preform manufacturing equipment, which can then start looking at recycled preforms in the sense of tape placement and such processes. Tooling is a big killer application. This was again a project with MIT at the time, looking at tooling with recycled fiber, and then that tool then would be used to produce composite parts either with recycled fiber or with conventional fiber, kind of closing the loop completely in a sense of the tooling application. And then I'm almost to the end. This is a lot of decommissioned aircraft. This was a project in Tupelo, Mississippi, where they stripped the aircraft in entirety, and then all the parts are then separated out. When the value of the parts becomes more than the value of the aircraft, is what we were told, is a good time to decommission a perfectly flying aircraft. In this case, then a lot of that reject, about 40,000 pounds of carbon fiber, is present in a standard Boeing, is my understanding, of which a lot of that becomes potential material for recycled use and closing the closed loop circular economy needs. In IACME, this could be a story that can summarize what I would say. So starting with the Dow Ford project, looked at essentially creating a form of a SMC kind of material, which then went into molding these tailgate panels for the Ford. And then the scrap resulting from that was recycled and recovered from Vertega. And that went back into compounded processing, and then went back into injection molding of a quarter fender back to the automotive industry. So I gave you like a 200-mile-per-hour view of what has happened. And I think it's best is to stop here, Ryan, and then see if you all have any questions.
Great. Thank you so much, Uday. Really appreciate that wonderful talk. Well, would ask anyone who has a question to please put it in the chat so we can manage that. And we do have a question already in the chat from Deborah Chung. So the question is, in the composite with both carbon fiber and carbon nanotube, how can you make sure that the matrix precursor enters the tiny space between the nanotubes? The nanotubes occupy volume and would reduce the fiber volume fraction in the composite. This would decrease the strength and modulus of the composite. How can this be addressed?
Oh, sure, great question. So I think I just want to clarify that all the projects I presented here today, there has been very little, I suppose, emphasis on nano materials or nanotubes. The nanotube application I mentioned is when they make the lay stitch thread, the thread for the lay stitch, that thread is built out of CNT fiber, as I understand it. So CNT is used to produce the threads to get the highest tensile strength, and that's then used to stitch the preform. So there, I think the main goal is to get the resin to infiltrate the fabric, of course, for the first, and then wet out the CNT threads. I'm not sure how much it will penetrate within the CNT, but that has not been looked at under any of this program that I evaluated today.
Thank you. The one question from Carlos Leon, can you comment on the advantages of helium resins over other thermoplastics?
Yeah, so helium, thanks for that, is a PMMA based resin, acrylic based. It has a reversible chemistry in that it acts like a epoxy or vinyl ester thermoset with viscosity of about 350-500 centipoise, which is very infusible. So you can cover a lot of fabric distance with helium and cure it like a thermoset. But once you're done with end of life, you can reverse the chemistry and reclaim the fibers. So that's the biggest advantage over other resins for that.
And then the last question that we'll have time for is from Matt Weisenberger. Is the TCF being pre-pregged directly on the carbon fiber production line, or on or off, I think might be the question.
Yeah, good question, Matt. So yeah, the patent that has been filed, etc., calls out that approach where a impregnation step could be added at the end of the line. That is not implemented yet commercially, if you will. But as far as taking the TCF and doing all the downstream impregnation in a secondary format has been demonstrated, and it is ongoing. But the goal is to transition it to an actual line where it becomes a very natural inline process.
Great. Thank you so much. Well, let's thank our speaker, Dr. Veda. Thank you so much. Virtual applause for your time and speaking with us today.